Exercise 8.3, problem 13, discussion. Let's read the problem. An iron right circular cone of diameter 8 cm and height 12 cm is melted and recast into spherical lead shards, each of radius 4 mm. How many lead shards can be made? So what is happening here is that you have an iron circular cone whose diameter is 8 cm, height is 12 cm. It is melted and recast into lead shards, okay, of radius 4 mm, and we are asked to calculate how many lead shards can be made. Again, here the same, the volume of the cone will be equal to the volume of a sphere into number of spheres. Okay, the volume will remain the same. Actually, it's a mass because the density is the same. It is a volume which we need to take here. Okay, so that's the key clue which you need to use here. Okay, so let's mark what is given in the problem. It's a right circular cone. The diameter is 8 cm. Watch out its diameter. It needs to be converted to centimeter. Height is 12 cm. And it is recast into spherical lead shards. And the radius is 4 mm. Again, watch out, it is 4 mm. So you need to convert this into centimeter. Okay. Let's list out what is given. Diameter of the cone is 8 cm. Which means radius is 4 cm. Half of it. Height of the cone h is 12 cm. Radius of the sphere small r is 4 mm, that is equal to 4 by 10 centimeters. Okay. What are we asked? We are asked to find how many lead shards can be made. Okay. How many lead shards, that is number of lead shards which can be made, is the one which we need to calculate. So let's list the formula. You have a cone and you have a sphere. So volume of the cone is given by 1 by 3 pi r square h. Volume of the sphere is 4 by 3 pi r cube. Now we will give you the hint. The volume of the cone equal to volume of the sphere into number of lead shards. So this is a cone which is actually recast into spheres, but you will get number of lead shards. So you need to multiply the sphere's volume into how many number of lead shards are there. That will be equal to volume of the cone. So this, if you put the formula, it is 1/3 pi r square h, which is the volume of the cone, equal to 4 by 3 pi r cube, which is the volume of the sphere, and let there be n number of lead shards. So multiplied by n. Okay. So this is how the problem can be solved. Capital R and capital H is for the cone, small r is for the sphere. Okay. So let's list the steps. So let n be the number of lead shards. Equate the volume of the cone to the volume of sphere and multiplied by number of lead shards. The cone is getting recast into sphere. So since this is small, you will get many spheres. So you'll have to find how many numbers are there. That needs to be multiplied by the spherical volume, and that will be equal to volume of the cone. And this on equation we get this. So equating, we get this equation. And if you can see, all the variables in green are known. Radius of the cone, height of the cone is known, radius of the sphere is known. Only the number of lead shards is not known. So which means it can be easily calculated. All you need to do is substitute the values of r, h and small r. You will be able to calculate n. Okay. So step 3 is substitute the values of r, the radius of the sphere, the radius of the cone, height of the cone in this formula, and calculate the number of lead shards. Okay. So pause the video here and try to work the problem on your own. Okay. So let's come to the solution. The diameter of the cone is 8 cm given here. Radius is 4 cm. Height of the cone is 12 cm. Okay. Radius of the sphere is 4 mm given here, and that is converted to centimeters, 4 by 10 centimeter. So let n be the number of lead shards. As told earlier, volume of the cone is volume of the spherical lead shard into number of lead shards. Okay. Volume of the cone is 1/3 pi r square h, and volume of the sphere is 4 by 3 pi r cubed, and let n be the number of lead shards. Okay. So that is multiplied by n. So substitute all these values, you'll get 4 by 3 into pi into radius is 4 by 10 into 4 by 10 into 4 by 10 into n, which is the number of lead shots, will be equal to 1/3 into pi. This is for the cone. Okay, this is for the spherical side, this is for the cone. So 1/3 into pi into radius is 4 centimeter, okay, into 4 into height. So if you look at it, this 3 and this 3 will cancel. Pi will get cancelled both sides. Okay, and what else will get cancelled? Okay, these two 4s can get cancelled with these two 4s. Okay, and then n will be equal to, okay, so n will be equal to, so this 4 and this 4 into 4 into 12 will remain there, and this 10 into 10 will come up, so it will become 10 by 4 into 10 by 4 into 10 by 4. Okay, I think we are not cancelling that 4 there, we are cancelling it little later. Okay, and this 4 comes down. Let me repeat here. So this 3 and 3 gets cancelled, pi and pi gets cancelled. Okay, then we are writing n is 4 into 4 into 12, and inverse this fractions, because when it comes to the other side it gets inverted. So 10 by 4 into 10 by 4 into 10 by 4, this 4 which is in the numerator comes down. So if you look at it, these two 4s will cancel, and this 4 will go 3 times. Okay, so 3 into 10 into 10 into 10 is 3000. 3000 divided by 4 is 750. So the number of lead shots will be 750. Okay, I hope you got it right. The key is the volume of the cone is the volume of the sphere into number of lead shots. Okay, that's all it is. And some of the key points is radius, diameter is given, so which you need to convert to sphere, radius, and then the radius of the sphere is given in mm, so you got to be careful, you have to convert it into centimeters. Otherwise it's simple, though it looks a little difficult. Once you write that equation, then it becomes very easy. Okay, I hope you got your working right. If not, please check and find out where it has gone wrong and correct it. If you have not understood the concept, please go back to the discussion part of the video and try to get the concept cleared. Okay, thanks for watching.